Tato, kia ora mātua Kauri, and Bruce for the kōrero prior to me. So I guess as Kauri and Bruce alluded to, we have the immense cultural, Māori and biological special properties of Kauri, and unfortunately, yes, now we're starting to shift to the kaupapa about the health of Kauri, and it is always horrible to follow up such speakers with the doomier side of this program. So my role today was to give a very quick introduction to Kauri Dieback itself. We have a huge range of speakers today who are going to go into a lot more on the microbiological aspects of Phytophthoras and other aspects of this. So I'm just going to really say, how did this emerge, and leave it to that. So in 2005, approximately, there were a lot of reports coming to Department of Conservation, Auckland Council, Land Care Research around these declining stands in Northland and Auckland about these. It was quite severe. There were lots of stands that had dead and dying trees in them across various locations. And the first question is, well, what's doing this? And the work of the late Dr. Ross Beaver at Manaki Whenua, pictured here, started to investigate and look at the causal agent of Kauri Dieback. And his work was pioneering in terms of finding out what was linking this tree death and this tree ill health to what we call Kauri Dieback, or what was it termed then, Phytophthora taxon Agathis. And the work of Ross showed conclusively that this was new to science. Although there had been a lot of history around Kauri Dieback, for example on Great Barrier Island or Aotea, there had been reports of Kauri Dieback for many years. Ross was the first person to link the emergence of this recent affliction. And his work really did show that Kauri Dieback was a very virulent plant pathogen of Kauri. And you can see an inoculated seedling that was killed totally in 2 weeks. So that led to the management agencies assessing this, and the Ministry for Primary Industries assessing this to be quite a threat to Kauri and its ecosystem, which Bruce has alluded to. It's not just Kauri, it's what it contains and what it supports, including ourselves. Kauri Dieback is basically a microscopic plant pathogen. It gets into the trees and through the root system. It is infectious, so that means it can invade the root system of Kauri, and it comes through the soil. So the life cycle here shows you really how this pathogen works. We don't know everything about the epidemiology between this organism and its host, Kauri, but what we do know is it does have the cycle of spore production, which allows it to survive in the soil, but it also produces motile or swimming spores, which allows it to move. This thing is alive in terms of some of the fungi that people might be familiar with have to move by wind or by movement, but this thing can swim through these mobile or motile zoospores that move through water. So the life cycle really showed us that it produces these structures, meaning it can spread. It can spread through Kauri forest. It can infect from tree to tree. Kauri roots do fuse together, so if an infected tree becomes infected, it can move to an uninfected tree through the root system. So that was a pictorial of the life cycle. So therefore, how does Kauri Dieback become soil-borne? Well, once the infection in the root zone is happening, it's producing these spores. These spores are little propagules, essentially like seeds, that are produced by an infected tree within the root system. And so obviously, as those roots live and die in the natural cycle, and as the pathogen kills these roots, these spores are released into the root zone. So anything in that root zone, beneath that tree, doesn't matter if it's a pig, a cow, a human riding a bike, whatever, if there is something moving soil out of this root zone, it will be moving PTA spores. And this is why there's been a lot of attention over the last 5 years about what do we do about soil movement. These things are moved in soil. We do have the waterborne phase that will swim through water films, but essentially these things hitch a ride. They hitch a ride. They're like stowaways. They're like rodents on ships. They're in the tread of people's boots. They're in the tracks of vehicles. And they're on animals. Anything that carries soil can potentially carry PTA. And we have some experts in the audience today who've also worked on research around how feral animals, for example, can move phytophthora. The issue for our program is, well, if it's in the soil, what can move it? And the track system. We have most of our tracks in New Zealand are either soil or gravel soil mixtures. We have isolated oospores right through track systems, so anything or anyone using a track system can pick up that muddy bit of soil and move it. And our surveys in the Waitakere Ranges have clearly shown oospores on the track network will cause infections on trees. And so this is 50 metres within the track network. The symptomatic or sick and dying trees that we see in the park are mostly in relation to a track system. However, 30% of sick or symptomatic trees are also away from the track network, right out here. So we have to admit there are other ways this thing moves once it's in a forest. Can't just blame the tracks, we have other things going on. For example, the zoospores swimming downstreams could go for kilometres. Hence, you might have seen in the last 5 years the rollout of management tools to try and disinfest movement of soil from different activities within the forest. So some of the symptoms, a lot of you have seen some of these talks or looked at our collateral, like our field guides. Well, what does it do? As I said, this is in the soil. It infects the roots. It doesn't just infect the roots, it kills the roots. This is a root killer. If you dig up sick Kauri, you will look at the terrible health of the roots. As it destroys the root system, it's destroying its symbiotic ancient association. These are root nodules. Kauri exists with mycorrhiza. So this PTA is actually rotting out the root structure of another organism and the Kauri itself. We don't even know what those mycorrhiza are. The lack of knowledge around Kauri mycorrhiza is a huge issue. As it moves up the root system, it moves to the trunk, it becomes what we call a collar-off. So in behind the bark, you will see PTA moving up the cambium tissues, causing these lesions behind the tree, behind the bark. As the tree tries to defend itself from the infection, it produces this gum or resin to try and stop the pathogen moving up and around the tree. So the weeping, bleeding we see on these trees is in response to this infection. And obviously, as the roots are killed, the mycorrhiza have their homes destroyed in the nodules, and the trunk system is rotted, the canopy is starved, and hence you get this canopy dieback. And you'll see all sorts of rates of decline with trees. We don't know the timing, we don't know from infection to death what that is. There's all sorts of environmental and soil ecological reasons for why trees succumb faster or slower, and why some don't appear to be sick and others are. So we still are in this state of unknown. But also we do have trees that suddenly die, sudden collapse, and usually that might be, say, in the last drought or dry period in Northland and Auckland, Waikato. Although the disease is not there, a lot of Kauri were afflicted by the drought, but the ones that were sick were, of course, even more at risk. It's like someone that's already ill getting a chest infection. The weaker, sicker trees will succumb quicker, and they can just suddenly collapse. The other reason that this was declared an unwanted organism and a pest is that no stage of the Kauri life cycle is immune. it takes out the young, it takes out the teenage successional forest, and it takes out the taoma iconic long-lived trees. So because of that, because of the virulence, because of these, the importance of Kauri, in 2009, as Dr. Paul Hutchison said, the Cabinet approved our program to exist, Kia Toitoi He Kauri, and so today you'll be hearing from some of the people that are involved in this work, from our partners. You've heard from Mātua Hori in terms of tangata whenua. We're all trying to work together to try and get some protection for this amazing taoma. So you'll hear about our management, but there are things you can do to help, and I'd just like to leave it there. Thanks.